Hello friends, Jamin here and welcome to this tutorial. We are going to be talking about Hasura. Now I don't know why I wasn't aware of this sooner, but in the last couple of weeks I've been hearing mention of Hasura, and I was wondering what it was. Now that I found out what it is, I could not help myself but make a tutorial on this because this is a very useful tool, specifically if you work with GraphQL servers in any capacity. What Hasura does is it provides a GraphQL layer on top of a Postgres database. Rather than having to go about setting up GraphQL as a server manually with all your resolvers, including creating your schemas and worrying about introspection and all that jazz, Hasura goes ahead and it sets it up for you automatically. All you need is a PostgreSQL database and it puts a GraphQL server on top of it. I don't know of many tools that do that. I know there are other alternatives, but Hasura pretty much seems to be the one I'm commonly coming across. Now Hasura is open source, so you don't need to pay for it. They do have pricing options, but I am just going to go and use the open source version of it. So on their homepage, if you go to run it yourself with Docker, and also their docs are very comprehensive. In your own time, you can go and read all of that. But what we're going to do is we're going to start from scratch using Docker. We're going to run one of these commands, which will generate a Docker compose file for us. So I've just copied that. Having copied this command, I'm just going to open the terminal, and then after opening this terminal, I'll create a directory. And then I'll paste the command that I copied, and then I'll run it. And then running that command should have created a docker compose.yaml file. So if I open this file with Vim, you see that it contains some instructions for setting up a Docker container from 2 images from PostgreSQL and also the Hasura GraphQL solution. Now it runs on port 8080, so I'm gonna come down here and change the port to 8081 because I've got an instance running on 8080 already. And then I'll just change this password to just say password, and I'll change it here as well. And I'll just leave everything else. And then after that, I'll run the docker compose command, and all of this is detailed here in the documentation. So doing this now should launch an instance of the Hasura dashboard in localhost 8081. So let's take a look at it. Okay, so logging into Hasura gives you this dashboard, and that's how you pretty much be working with it. It provides this interface for testing your GraphQL queries, as well as providing a UI for creating tables in your Postgres database and managing that. So here, for instance, so if we come to this GraphQL interface and we click on docs, at the moment there's nothing here because we don't have a schema yet. So what we're going to do is we're going to be using this tool to create a database for managing a list of recipes. So the tables we're going to be working with are recipes and ingredients. So I've got a model of that here. So it looks like this basically. 2 tables having a one-to-many relationship. So each recipe will have many ingredients. The recipes table will have these fields, and the ingredients table will have these fields, just an ID, a name, and then the recipe it's connected to, right? So having this now, we are going to go to Hasura and then go ahead and create these tables. So to do that, we'll come to the data menu here, and then under schema, we'll just click on create table. We'll specify a table name called recipes, and then we'll specify our columns. So the first column is our ID column. The column type will be an integer, auto increment, because that will be our primary key. We'll set our second column, which is the name, and then the column type of that will just be a text-based column. And then our other column is description, which will also be text. And in fact, for now, I'll just leave these three fields just so we can get a quick example going. I'll come down here to primary key, and then I'll select the ID column as the primary key. And everything else I'll leave alone for now, and I'll click on add table. So once this table has been added, if we go back to data, if we come to GraphQL and we look at the Explorer, immediately you see that the documentation for our GraphQL schema has been extended to have our recipes listed. So all of these are auto-generated by Hasura based on the schema of our table that we just created. And if I click on docs here, we've got auto-generated queries, mutations, and subscriptions. So if we click on query, we've got this query example here with recipes. So we can, in fact, test this out by making a query to retrieve a list of recipes. So let me change this bit, and we'll say recipes. And then for each recipe, we'll get the ID and name. Of course, if I do this, then the response is pretty much empty because we don't have any recipes added. But looking at this, we can come back to our data and go to our table that we created, and we'll insert a row here. And because I'm recording this the day directly after Thanksgiving, the name will be roast turkey with lemon and garlic. And then the description will be lovely for Thanksgiving or something like that. Then we go ahead and save it. Okay, so once you save it, it just says inserted, and then this button turns to insert again, so we can go ahead and modify these fields. And once we click insert again, it will add another row. But for now, we only just need one row to work with. So if I come back here and I run this query again, then in the response, we get that. Okay, so let's go ahead and add another recipe. I'll click on recipes, I'll insert another row. And for my next recipe, I'll just put pumpkin pie. And then I'll copy this description. And I'll save that. And if I come here and I make another call, then we get that. So far, we're making queries. There are three different types of queries we can make. So there's recipes on its own, there's recipes aggregate. So we can make aggregate calls by using this method, or we can do recipes by primary key. So we can query a particular recipe based on the primary key. So if I test this out right now, like so, we need to define some query variables. Well, one query variable, so ID, which is of type int. And then in here, we can do ID like so. And I'm getting this from over here. This is the input it expects. And down here in query variables, we need to go ahead and define our ID field. And for instance, we just say 2. So if I go ahead and run this, then we get exactly 2 back. We can also make mutations. So mutations includes the other sorts of operations. So we've done read so far, so we can do delete, we can insert new ones, we can update. So let's go ahead and insert a recipe. So I'll do mutation, insert recipe, and then I'll create a variable called objects, which takes in recipes insert input. So this again is being taken from this one here. So in our mutation, therefore, is insert recipes. And then for our objects input, we pass in the objects variable. And the response is of type recipes mutation response. And these are the fields in the response. So we want to be returning any of these fields. So let's just say ID and description. So from this now, we need to define our query variables. So for objects, it takes in a list, and then each item will specify a name, which will be another Thanksgiving meal. So easy turkey crown. And then description, I got that. Okay, so let's go ahead and run this. And there we go. We have our new recipe inserted. Let's perform another operation. For instance, let's do a delete. So I'll have another mutation. And this delete recipe will take in an ID, which is of type int. So specifically, I am running this mutation, delete recipes by primary key. And then our ID will be the value of ID from our query. And then the result of this operation just returns the details of the recipe that was deleted. So we just have ID name. And in our query variables, we need to define the ID we want to be deleted, which is our integer. So if I go ahead and run this, then it's deleted it, and we get the details of what's deleted. So right now, to confirm that it's deleted, if I go ahead and I make a query, in fact, let me copy this. Now comment this out, and we want to query recipes. Like so. Hold on, let me go back. Oh, right. Sorry. Let me get rid of that. And I do that again, and there we go. We got our recipes. And the item with an ID of 2 has been deleted. Okay, so I mean, hopefully you begin to see how powerful Hasura as a tool pretty much is. The steps to even set this up was just running a Docker command, which launched this interface with an inbuilt compiler for doing all of these things for us. I'm going to go ahead and create another table. And we'll call this table ingredients. If we come back to our database diagram, so each ingredient has a recipe ID, an ID and a name. So let's do that now. So recipe ID, this is of type integer. And it's got its own ID, which is an integer that auto increments, and then the name, which is of type text. The primary key is our ID. And because we have a relationship between recipes and ingredients, i.e. a single recipe can have many ingredients, we'll define a foreign key where the reference table is our recipes table, and then we want to connect to the recipe ID we define here to the ID column in our recipes table. Also, with these options on update, I'll just leave this like so. However, on delete violation, I want to select cascade. So what that means is that if I go ahead and create a recipe with ingredients and then I delete that recipe, there's no point having the ingredients still existing in our table when the recipe is connected to has been deleted. So on delete violation, I'll select cascade. I'll click on save, and then I'll add our table. Let's go ahead and insert a row, and I'll add an ingredient to our first recipe, which was the roast turkey with lemon and garlic. And I'm going to go ahead and copy and paste these ingredients. I'll save that, and I'll go ahead and I'll add another one. And then one more ingredient. So if I go to browse rows, then we've got these ingredients added. Let me insert an ingredient for our other recipe. So this is our first one, and this is our second one. Okay, so we should have these now. I'll come to our GraphiQL tool, and then I'll make this query, and let me clean this up. So if we look at the docs here, we see that a couple more methods have been generated based on our ingredients table. So if I make a query for ingredients and run that, we have all of that. And we can also log out the recipe ID, and which gives us that. Okay, we can also perform specific queries. So if you look at these options here, you can actually experiment with that. So let's just say we can specify a limit. For example, so if I go ahead and set the limit to 2, then we got 2 results. Let's try some of these specific ones. So yeah, let's try where. Actually, I'll keep limit, and then I'll set where, which is, the schema is ingredients boo exp, and then I'll pass that in here. So if we look at this, so where we'll take in a map, and in the map, these are the keys we need to specify. So we can say where recipe ID is 2. Wait, recipe ID, and if I click on that, yeah, recipe ID takes in an object, and we can say where recipe ID equal 2. Okay, so if I run this, then you get nothing because it doesn't exist. We deleted it earlier. So let's try 3. Okay, then we got these 2. So this is a very good tool to use for any projects that you're starting off with, which requires a GraphQL backend. Let's make another query, which includes the recipes and their associated ingredients. So how we're going to do that is we can come down here back to recipes. So I'll simplify this again, recipes. So for each recipe, we'll get the ID name. I'll also log out the description. Before I resume, let's check and confirm something quickly. So I'm going to come back to data. Okay, so if we notice here, we need to ensure that we are tracking foreign key relationships. So if we hover over this, it says relationships inferred via foreign keys that are not exposed over the GraphQL API. So we need to expose these over the GraphQL API, which means if we come back here and then we click on query root and then we come down to recipes and we click on the response, we see that we are also able to pull in ingredients that are related to that recipe. We've got the methods for those. So that's what I'm going to do here. I'm going to pull in the ingredients, and for each ingredient, I'll get the ID and name. And I'll get rid of these query variables. So if I go ahead and run this, then this is what we get. Like so, and let me log out the recipe ID just to make sure. Yeah, there we go. Recipe ID matches the ID, and same here as well. Okay, what else can we do with this? Oh, let's perform a delete operation. So if I go ahead and delete a recipe, it should also delete the ingredients that are associated with that recipe. Because if you remember back, when we were creating our ingredients table, we selected the cascade option. So let's do a delete. Mutation. So we'll say delete recipe, and then which will take in an ID. So we are going to invoke the delete recipes by primary key operation. And then I'll just return the name in the response. And then here, let's specify our ID, which is 3. So if I go ahead and run this, then it's deleted that. And when we query our recipes again, then we only get that one recipe. And if we query our ingredients, and let's get rid of these, and I do that, then we only get the ingredients that are connected to the recipe that still exists. There are a lot more features that Hasura provides. So if we look up here, there are features relating to certain actions, remote schemas, even events. We can configure events in here. So if, for example, I go ahead and I create an event, and for instance, this will be an echo event, and this event will be related to, let's say, recipes. And for any operation we make on the recipe, we can trigger a call to a webhook URL. And for this example, I'm just gonna use the default. And if you're wondering what this website is, it allows us to test sending requests and receiving responses. So we're just gonna make a post request. So if I come back here, under advanced settings, you can specify some retry logic and some headers to send across. I don't care so much about that, but let's create this event trigger. If I come back to our GraphQL interface, and then we go ahead and add a recipe. So insert recipe, like this one again, and then I run it. When we come back to events and we go to echo and processed events, we see that an event has been logged here. So an API call was made to http://bin.org/post, and this is the request details, and this was the payload that was sent along with the headers and version, and then the response includes all of that. So http bin sends a response back with the data that was sent across, so all of that. is the data that we sent, which is this stuff here. There are also cron tasks. You can configure one of scheduled events, but I'm not going to cover this. Take a look at it yourself and experiment. I would love to do a follow-up, perhaps managing all these recipes via an app, a Flutter application. Let me know down in the comments how you feel about this. If you've enjoyed this video, do hit the like button. Also share this video. If you're not a subscriber, hit the subscribe button and the bell notification icon so you don't miss out on future tutorials like this one. If you've got any feedback or any general questions about the content presented here, let me know down in the comments below, and I'll see you in the next one. Thanks for watching.